I'm going to move on here. How valence electrons create compounds. So this is basically what we just did. Calcium has 2, oxygen has 6. When you put them together, they become calcium oxide, CaO, with 8 valence electrons, creating a full energy level. Okay? 1 atom of calcium, 2 chlorine atoms. Okay? Calcium has 2. Total, we have 14 over here. Okay? So calcium gives 1 valence to this chlorine. It gives 1 valence to this chlorine. Okay, there, this is better. Okay, so calcium gives 1 valence to this and 1 valence here. So we're going to drag and drop for this element. Drag the 5 atoms to create a chemical formula. How many aluminum atoms? How many oxygen atoms? How many total valence electrons? All right, so we have oxygen, and we have another oxygen. And then we have aluminum. And we have aluminum. Huh. I wonder how this one is going to work. So I think that we're going to have to put the aluminums together. Okay, so we have 2 aluminums. Give me 1 second. See if I can make them even formatting wise. All right. Oops. This oxygen's going to bond here. And we're going to put this oxygen here. And this oxygen here. So what we're seeing is we have 2 atoms of aluminum. 2 atoms of aluminum. And we have 1, 2, 3 atoms of oxygen. Okay? So aluminum has 3. Aluminum has 6 total. Okay? So it's going to give 2 to each oxygen. Okay? So aluminum has 6 total. And then we have 6, 12, 18, 19, 20, 21, 22, 23, 24. So we have 24 valence electrons total. So aluminum gives 2 here, 1 here. This aluminum gives 1 here and 2 there. Okay? So if we have 6 aluminum total, each oxygen is getting 2 valence from aluminum. Okay? And for our chemical formula, ensure the first letter is capitalized and the second is lowercase. So that's for an element. So for aluminum, it needs to be capital A, lowercase l, just like it looks in the picture. And then oxygen is a capital O. Okay, but we need to make a subscript. A subscript tells us how many atoms of that element we have. And we're going to talk about subscripts a lot until Wednesday. 2 elements of aluminum, 2 atoms, 1, 2, and then 1, 2, 3 of oxygen. Okay? So that's how we do 1. Now let's do the second. Okay, so we have 1 big ol' atom of carbon. And we already did this one on paper. Okay, so real quick, I'm going to put oxygen, oxygen. Okay, so let's go ahead and do this. We have 1 atom of carbon, one puzzle piece of carbon. And we have 2 pieces of oxygen. Okay? And the total valence electrons is 12 plus 4 is 16. So 8 and 8. And the chemical formula is capital C, capital O, 2. Because we have a capital C and we have 2 capital O's. Element 3. Okay, so we got a lot of nonmetals here. So we have 2 elements, 2 atoms of hydrogen, and we have 1 atom of oxygen. Water is a weird one. So we're making H2O right here. Hydrogen, hydrogen. Water is almost never alone either. So 6, 7, 8. So we have 2 atoms of hydrogen. 1, 2. And we have 1 atom of oxygen with 8 total valence electrons. And this is hydrogen and oxygen. It's H2O. H12O. Okay? Element 4. So we have silicone, which has 4. It's going to give 2 to this oxygen, and it's going to give 2 to this oxygen. So we have 1 atom, 1 puzzle piece of silicone, and we have 2 puzzle pieces of oxygen. Okay, and the total number of valence electrons is 16. 6 plus 6 plus 4. And the chemical formula is capital S, lowercase I, capital O. We have 2 O's. Okay? What did you notice about the number of the valence electrons? So you guys can respond to that in the chat. What did you notice about the number of valence electrons? Okay, so I'm going to type that in. What did we notice about the number of valence electrons? They were always even. They were always multiples of 8. These examples always equaled 16. Okay, very good, guys. The purpose of this was to show you guys how we use valence electrons when we create bonds and how diverse those relationships can be. For example, with our aluminum, chlorine, and oxygen. Okay?